So it's this way was. Suppose a progressive wave, right? A wave travels, say, in positive x direction, so, and meets a reflector, something that reflects it back, so that the reflected wave will superimpose on. The reflected wave will travel in the opposite direction, right? And they superimpose on each other. Now, only condition is that previous one you can see superposition of two progressive waves, right? So you have a wave which is progressing in positive x direction. You have another wave of same amplitude. That's what they say. So one is traveling along positive x direction, the other one will travel along negative x direction. Condition is both the waves should have the same amplitude, right? The amplitude of both the waves should be the same. They should have the same frequency. They should travel with the same speed in the same medium. So one is traveling forward, the other one is traveling in the opposite direction. So when they overlap with each other, you will get a pattern like this. Such waves, we call them as stationary waves or standing waves. So two waves traveling in opposite direction in the same medium with the same speed, with same amplitude, and then with same frequency. When they overlap with each other, they give rise to waves, like stationary waves. The wave pattern will be like this. Now, if you see, there are points where the particles will not vibrate. These points are called nodes. There are points where the particle of the medium, suppose the waves are traveling, boys, if the waves are traveling through air, then air molecules begins to vibrate. Now, if stationary waves are produced in air columns, boys, understand this. If you produce stationary waves in air columns, then at like this, you can have a wave pattern like this. You can have pattern. This is air column. I have given it to supervisor's office. Supervisor's office. The same thing happened. So the waves will overlap with each other. Boys, at these points, what we call it as node, the air molecules will not vibrate. Now, there are other points called antinodes, where your air molecules will vibrate with maximum amplitude. Are you clear, boys? What is a node? What is an antinode? 11B. 11B.
Yes, ma'am.
Yes, ma'am.
Only few boys. Now the entire for the entire class, Vishesh, Yusuf, and Zubair will answer. No one will. If at all I'm asking, shall I move for the next slide or whatever it is? These three students will answer. Vishesh, Yusuf, and Zubair. Fine, boys. So nodes and antinodes are formed when stationary waves are produced. And one thing you all should understand, the distance between three consecutive nodes or the distance between three antinodes. Now this distance is the wavelength lambda. Are you clear? The distance between consecutive nodes or consecutive antinodes is lambda. The distance between nodes of two antinodes, next antinodes, next to next node is lambda by 2. The distance between a node and an antinode is lambda upon 4. Is that clear? Is that clear, boys? What class is this?
Yes, ma'am.
Okay, fine. Vishesh, what is the distance between whatever I have marked within this node, and a node? What is this distance? Yusuf, what is this distance between a node and a node?
Is it lambda?
It is lambda. Fine. Next. Austin, what is the distance between these two nodes? This distance. What is the distance? Austin?
Yes, ma'am.
What is the distance between these two nodes? Look at this, boys. What is the distance between two next to next node? Can you see what right now I'm? No, that will be lambda by 2. Is that clear, boys? Distance between three nodes, once again, distance between three nodes, it is lambda. Distance between two consecutive nodes, lambda by 2. Same thing applies for antinodes also. Right. Now, what is this? Is a node.
Ma'am,
Yes.
won't these two waves just cancel each other out?
They will not cancel each other. At these points, it cancels out. The resultant displacement will be zero only at nodes. They will not cancel out each other. The conditions are there, right?
Yeah.
Conditions are there. Okay. Now look at this, boss. Between a node and an antinode, this distance, a node and an antinode, will be lambda by 4. Are these things clear, boys? Are these things clear? Tell yes or no.
Yes, ma'am.
Okay. So did you
Ma'am,
write
can
what
you
is?
explain
Yes.
the second point in
Yes.
that?
What happened?
Ma'am, uh, ma'am, can you explain the second point in that slide?
Between two, sorry, between two nodes.
No, ma'am. Stationary waves occur by resonance only at
Okay.
natural frequencies.
Okay. Suppose if I have a wave, right? Right. For a diagram. Right. This is a progressive wave which is moving forward. Then when it gets reflected back by a fixed end, right? 180, see, look at this. It's 180-degree reversal. A progressive wave moves forward. I'm talking about this diagram. The, when it gets reflected back, you can see 180-degree reversal. So which means the wave is progressing, boys. The wave is keeping on progressing. The reflected wave is also progressing. So, and when they overlap, you will have a pattern like this. When they overlap, you will have a pattern like this. I think so. I had shown a video presentation where standing waves are produced in a rope. Have you seen that? Boys, did you watch that video? Standing waves produced in a rope, string.
Yes, ma'am.
Yes. So the waves are progressing. The wave is continuously moving forward. The wave is continuously reflecting back. When that is why progressive wave. The waves are continuously progressing in the forward direction, continuously getting reflected back in the opposite direction. If they have the same speed, same amplitude, same frequency, they will overlap. When they overlap, they form such patterns, what we call it as standing waves or stationary waves. The characters are of a standing wave is you have nodes and antinodes. Nodes are the point where your molecules, if the wave is traveling through air, then the air molecules at nodes will not vibrate. At antinodes, the air molecules will have maximum amplitude. Is that clear, boss?
Ma'am, it should be the other way around, right?
Right?
Like, can you
At nodes,
explain?
I
Uh,
think no, no. At nodes, there will be no displacement, boys. At nodes, sorry. At nodes, there will be no displacement. So,
Ma'am, we did all this last class, ma'am.
okay, fine. Now we'll go for this. Standing waves in a stretched string. Did we do this?
Ma'am, we did this also, ma'am.
Okay.
Slide after this.
Okay. Slide after
Yes.
this, we didn't.
Yes.
Okay, fine. We'll go for We'll start with this first. First one, right, was first mode of vibration. First mode of vibration. So you have a string, entire string. This string has a length L, right? Both the ends are fixed. The length of the string is L, both the ends of the string is fixed. You are creating a wave pattern like this, right? So you have a node at a fixed end, another node at a fixed end. So what is the length of the wire? The length of the wire is L. Now, between two nodes, what is the distance, boys? Between two nodes, what is the distance? Just now you have done. What is the distance between two nodes?
Ma'am,
Lambda by 2.
oh, sorry.
Lambda by 2? Okay. So let me characterize. This is the first mode of vibration. Right, boys? In a string, in a stretched string, you have created a wave pattern like this. You have created a wave pattern like this. So, which means you have two nodes, each at one end and one antinode. Then, if you create such a wave pattern in a stretched string, the string will vibrate with a certain frequency. You want to find what is this frequency. Are you clear, boys? If you set a wave pattern in a stretched string, later on we'll see how you are creating a wave pattern. So you have created a wave pattern in a stretched string, which means just at this point is connected to a hard support. At this end, you're putting a load. So the wire is under tension, it can vibrate. So at both the fixed end, you're creating a node and one antinode. So in this mode, your wire will vibrate with certain frequency. That is what you need to find. Now look at this. Between two nodes, the distance is half of the wavelength. So then what is L? N becomes equal to lambda 1 by 2. Or what is lambda 1? It is 2M. Correct, boss? Is that fine?
Ma'am, could you repeat again? Your voice was cracking.
Okay, fine. See, between two nodes, what is the distance between two nodes? It's always half of the wavelength, correct? It's lambda 1 divided by 2. Because this, in this mode, your wire will vibrate with certain frequency. That's what to differentiate, I have put lambda 1. And the entire length is equal to lambda 1 by 2, or your wavelength is equal to 2 times the length of the wire. Copy down this fast, boys, because very important 3-mark question. With the diagram, you have to continue. Copy down. Next part, this will be the first part for this. What will be the second step for this? Wave equation. Now, according to wave equation, you know the speed of the wave v is equal to the frequency. You know wave equation, v is equal to nu lambda, right, boss? So what is your aim? Your aim is to find nu 1. What is nu 1? V by lambda 1, right? So what is the velocity, boys? What did you have for velocity? Since, let me mark this as equation 1. Let me mark this as equation 2. Since the velocity v is equal to root of t by m, where t is the tension of the wire and m is the mass per unit length, substituting equation 1 and 3 in 2. Will you do this, boys? Can you substitute this? So then what is nu 1? Nu 1 is, what is v? V is root of t by m, correct, boys? Now what is lambda 1? 2L. So I can write nu 1 is equal to 1 by 2L root of t by m. Is that correct? And this frequency we call it as fundamental frequency. Copy down. Or we call this as first harmonic. Is that fine? 11B?
Yes, ma'am.
Tej, Jatin,
Yes, ma'am.
Hitesh?
100%.
Those who have completed this, can go for two modes of vibration. Second mode. I'll just draw the mode. Just try when others are writing. You can try. The others can try this way, which means always at the fixed end you should have nodes. So the second mode of vibration you will get like this. At the fixed end, both the ends of the wire is fixed. At both the ends you should get nodes. So this is the second mode of vibration. Draw this, find what is the length equal to, and same way you have to proceed. Others can start, those who have completed. Bus, shall I move for the next one? Ayan?
Yes, ma'am.
Shall I go for the next slide?
Yes, ma'am.
Okay. Even for others, so now let us go for the second mode of vibration. Second mode of vibration. The second mode of vibration, you have a node, and a node. So what is the distance? Distance is L, but what is the distance in terms of wavelength? That will be lambda 2. So L becomes equal to lambda 2. Correct, boys? L is equal to lambda 2. So, okay, fine. What is wave equation? What is the wave equation? V is equal to nu 2 lambda 2. Sorry. Or V is equal to nu 2 will be equal to V by lambda 2. So let me mark this as equation 1. This is 2. But you know what is V? V is equal to root of T by M. So mark this as equation 3. Now you substitute 1 and 3 in 2. Boys, is that fine what I'm doing? Is that fine, boys? So it will be 1 by L root of T by M. Yeah. So this is called second harmonic. This is the frequency. And what do you infer, boys? Nu 2 becomes equal to 2 times nu 1. This is called second harmonic.
Ma'am, the first one, it is first harmonic.
Yeah, first harmonic or fundamental frequency. This is second harmonic. Sometimes they call this as first overtone. I think so. Those who are familiar with musical instrument, you will be knowing about overtones or fundamental note or something we'll call, right? So we'll keep it as second harmonic. The previous one was first harmonic.
Ma'am, the
Yes.
M stands for?
Yes, mass per unit length.
Ma'am, so we can write rho instead of it to avoid confusion.
No, sometimes we do. That is mass per unit volume is taken as rho. Here, what we generally do is in grade 12, we represent it with a mu. Right? Mass per unit length, we represent it with mu. Mu in optics is refractive index.
Ma'am, can you tell again what do these frequencies mean?
Which one?
These frequencies that we're deriving, the formula.
Okay. No, which means suppose in a wire, right, boys? In any wire, if you create a wave pattern like this, if you're creating a wave pattern in this way, you can create a wave pattern. You can connect the wire to electrical mains. You know what is your electrical mains, boys? You can connect it to electrical mains so that the wire begins to vibrate. You can change the tension also. Tension means the load. You can change the tension. You can connect it to an electrical mains, or you can make the wire to vibrate by bringing a vibrating tuning fork. You can make your wire to vibrate when you can change the mode of vibration. Mode of vibration means if you make the wire to vibrate in this way, so that only one first pattern is formed, then the wire will vibrate, say with a frequency of 200 hertz. I'm just telling you the same wire, if you make it to vibrate in this mode, right, its frequency might be 300 hertz. So you can change the frequency of the vibrating string by changing the modes of the waves, right? So in each mode, the wire will vibrate with different frequency. If it vibrates like this, if a pattern, when the wire is vibrating, if a pattern is formed like this, then it vibrates with a frequency mu2. That will be 2 times the previous one, right? Shall we go for the next one? Third mode of vibration. Well, shall we go for the third mode of vibration?
Yes, ma'am.
Yes, ma'am.
Or you yourself draw the third mode of vibration. Will you draw this? Third mode of vibration. That is a mu3. Also, you can have so a node, and a node. So what is the distance between these two boys? These three. I can go for lambda 3. So what about this lambda 3 by 2? Correct, boys? Is that fine? What I'm doing? Is that correct? Sorry. Till this, what is the? This is L. So L becomes equal to lambda 3 plus lambda 3 by 2. So what is L? L is equal to 3 lambda 3 by 2. Or I can write lambda 3 is equal to 2 by 3L. Is this fine? Should anyone wants me to explain? 11b. So now according to wave equation, velocity V is equal to root of T by M. Sorry. V is equal to nu3 lambda 3. So what is nu3? V by lambda 3, equation 2. But what is the velocity, boys? Velocity is equal to root of T by M. Sorry. T by M. So I'll mark this as equation 3. Now substitute 3 and 1 in 2. So what is that you will be getting? V is equal to, will you do this? Let me wait. Will you do this, boys? Get me an expression for V. Harish, Dheeraj,
Ma'am, for new, right?
sorry, new. So your frequency of vibration, I want you an expression for nu 3. Are you getting 3 by 2 L root of T by M? So
Yes,
nu
ma'am.
3 is equal to 3 times 1 by 2 L root of T by M. So nu 3 becomes equal to, what is this? Nu 1, 3 times nu 1. So this is called third harmonic. That's it, boys. So you will get this as a 3-mark question also.
Ma'am,
Yes.
like in the final answer, what is this L? What does the L represent?
Length of the wire,
All right.
length of the string, capital L. Have you completed, boys? Samuel? Has Samuel come? Has Samuel is there in the class? Surya?
Yes, ma'am.
No. Have you completed, Surya?
Yes, ma'am.
Danish? 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 Boys, those who can't answer, please put your message in your chat box. Johan? Johan? Can I move for the next one?
Yes, ma'am.
Fine, boys. So next one, the first one was transverse wave in a stretched string. Next one, you will be producing stationary wave in open-ended pipe, organ pipe or air columns. That is closed at one end. Sorry, there is an error here.
Ma'am,
In case of yes. What
like in the
happened?
previous derivation of when you substituted V equals to root of T by M, is there any constant supposed to be there?
No
Like when
need,
we,
because we'll take, let us check the constant as one itself.
okay, ma'am.
Now look at this stationary waves, especially in your musical instrument like flute. When you see the musical instrument flute, both the ends are being open, both the ends of the tube is open, right? When you produce waves, now what is going to happen? The air molecules are going to vibrate and they produce a pattern like this. So in each mode of vibration, in each mode of vibration, we need to find what is the, if in this organ pipe, if a pattern is formed like this, with what frequency the air molecules are going to vibrate, new one we have to find. If you produce a waveform like this in the same organ pipe, right? With what frequency now the air molecules will vibrate. Same way, when the pattern produced keeps changing, the frequency with which the molecules of the medium vibrate also changes. So you need to find with what frequency the air molecules are going to vibrate. Write the heading, boys.
Ma'am,
Stationary waves. Yes.
is it a open pipe or closed pipe?
No, this is, sorry, boys. This is opened at both the ends, right? So opened at both the ends. Write this heading.
Okay, ma'am.
Ma'am, do we have to draw this?
No, drawing is next, boys. We'll draw the diagram for each mode of vibration. Only thing is that write the heading. Now you start writing the speed of sound waves in a medium, right? P is the pressure of the medium, rho is the density of the medium, and gamma is the ratio of the specific capacity at constant pressure to constant volume. That's it. Just write these and then we'll go for, and keep this in mind, boys. In an organ pipe like this one end is open, the other one is also open. Wherever you have openings, you will have antinodes. Wherever you have a closed end, in a string, both the ends are closed. Whenever you have a closed end, there will be a node. Suppose if one end of the pipe is closed, only other end is open, then this is a closed end, boys, this is a closed end. At a closed end, you will get a node, and this is the open end. You will get an antinode. This is a closed end. So whenever you have closed ends, you will have a node. Whenever you have open end, you will have antinodes. Are you clear? So don't draw the diagram right now. You copy down the speed of sound waves in a medium.
Ma'am, what's the formula?
B is equal to root of gamma P by rho, where gamma is Cp by Cv, P is the pressure of the medium, rho is the density of the medium. Have you completed, boys? Just check, I'm on slide. I don't know how much time is left. Can you check?
Ma'am, 12 minutes.
Okay, fine. I think so. We'll be able to. Again, you need to draw. So the first mode of vibration, I'll do the finding the expression for new one. The second, third, you have to do by yourself. Shall we go for it, boys? 11B, Taisir.
Yes, ma'am.
Sanfa.
Ma'am, later on should we draw these diagrams?
No, I'll do that. Don't draw the diagram right now. Only the theory part you write. Have you completed the theory part, boys? Have you completed the theory? Okay. Now next, right, boys. First mode of vibration. Draw the diagram. What is the length of the tube? Now, just tell me what is the distance between two antinodes? It's lambda 1 by 2. Correct? Between two antinodes or between two nodes, it's lambda 1 by 2. So L becomes equal to lambda 1 by 2. Or I can write what is lambda 1, boys? 2L. Is that fine? Now next, according to wave equation, okay, what is the wave speed of the sound wave? It is root of gamma P by V is equal to nu to lambda 2. So what is nu 2? Nu 2 will be V by lambda 2. So let me mark this as equation 2. Correct? But what is the speed? V is equal to root of gamma P by rho. This is equation 3. Now substituting 1 and 3 in 2. So what is nu 2 then? Frequency nu 2 becomes equal to 1 by 2L root of gamma P by rho. So this is new one. No? Sorry, it's that everywhere I'm making mistakes. First, so new one, all new one. So what is this you call it as first harmonic? Is that fine? Hitesh,
Yes, ma'am. Yes, ma'am.
Sanfar,
Yes,
Abhishek, can someone try the second mode of vibration? By second mode of vibration, you should have again two antinodes at both the ends. So one more antinode at the center. Can someone try the second mode of vibration? Eleven B, you're quiet. Are you doing your work, boys? 11B, Nabil, Nabil, Surya,
Yes, ma'am.
have you completed Surya?
I'm doing for the second one.
Okay, shall I go for the second one, boys? Shall we go for the second one?
Yes, ma'am.
Second mode of vibration. The diagram is over here. Now this will be the length of the wire. Was between two antinodes, it is anyway between three antinodes. This is just the wavelength. So that is lambda 2. So L is equal to lambda 2. So that becomes equation 1. Then, according to your wave equation, V is equal to nu 2 lambda 2 or nu 2 is equal to V by lambda 2. So this will be equation 2. Then, but your velocity V is equal to root of gamma P by rho. This will be equation 3. Substituting 3 and 1 in equation 2. So you will get nu 2, sorry. You will get frequency nu 2 is equal to 1 by L times root of gamma P by rho. This is called second harmonic. And then nu 2 is equal to 2 times nu 1. Just check whether you are getting this. Have you completed?
No, ma'am.
Steve, you are there in class? Aaron? Aaron?
Yes, ma'am.
What is Steve? Aaron? Derek? Dheeraj?
Yes, ma'am.
Is it Dheeraj? No, who was answering now? Was it Dheeraj or Derek?
Derek.
Okay.
Ma'am, should you do the next one?
Yeah.
The third
Shall I
mode
go
of
for the next? Yeah. Shall I go for the next one, boys? If you need, I'll just put this in. Okay, next one. Can you go for the third mode of vibration? Here, this is L. What is between 3 is lambda 3, and this is also lambda 3 by 2. So L becomes equal to lambda 3 plus lambda 3 by 2. So L is equal to 3 lambda 3 by 2 was, or I can write lambda 3 is equal to 2 by 3 L. Is that fine? Is that correct? What I'm doing? So what is a wave equation, boys? V is equal to nu 3 lambda 3, or nu 3 becomes, I'll mark this as equation 1, V by lambda 3. So that is equation 2. But what is your velocity? V is equal to root of gamma P by rho. So substituting 2, 3 and 1 in 2. Substituting equation 3 and equation 1 in 2. So what is that you are going to get? Frequency nu 3 will be equal to 3 by 2L root of gamma P by rho. This is called third harmonic and nu 3 is equal to 3 times nu 1. Fine, boys. Have you complete this, boys? So I think so in sixth period, we'll move for wave pattern in one end closed organ pipe, the other end is open. Then last topic is beats. Only that much you have in this chapter, and possible the numerical. So tomorrow I'll start with thermal properties. Fine, boys? So in thermal properties, then in thermodynamics as well as in kinetic theory of gases, we will be doing whatever is CBSC has suggested, but you will be tested only on few topics. By today, you will get your portions for your final exam. So upcoming 3 chapters, whatever CBSC has suggested, we'll be doing it. But out of that, only few topics will be tested. Is that clear, 11B?
Yes, ma'am.
Today you will get this portions for your final exam. Completed, boys.
If we complete, can we leave?
You can leave. Yes,
Thank
boss.
you, ma'am.
It's time up. Is it time up?
Yes, ma'am.
Okay, you can leave, boys. You can.
Thank you.
Thank you, boss. Those who have completed can leave.
Thank you, ma'am.
Thank you, boss.
Thank you, ma'am.